Okay, so in this question, they give us the mass, 65 grams, okay, and they tell us that it's water. Right, so I can calculate the molar mass. Water is H2O. That's going to be 1.01, my hydrogen, and there's 2 of them, plus my oxygen, to give me a molar mass of 18.02 grams per mole. Okay, so I know mass, I know molar mass, and I'm looking for the number of moles, which means I don't have to manipulate the equation. I just plug in mass over molar mass. Okay, that will give me my 65 grams divided by my 18.02 grams per mole. 65 divided by 18.02. All right, so we got 3.61 moles. Everybody all right with that one? Now, if I put one like this on your test, which, I probably would, I'm going to put the compound's name in words, just like I did there. But I would be aware that I'll probably pick, like for a question like this where the mole part is easy, I'll probably pick a more difficult compound. Okay, like I might pick an ionic compound with a polyatomic ion in it, okay, or something like that, so that I'm making sure you know how to do the formula part, okay, because that's an important part of it. Okay. All right, so for this one, we're looking for, what's the mass? So we're looking for little m this time, of 8 moles, so we know N. Okay, of magnesium chloride. And again, that's how I would do it on the test. I wouldn't give you the formula, I'd give you the name. All right, so big M, magnesium with chlorine, that's a -2, that's a plus, sorry, that's a -1, that's a +2. Okay, so we got MgCl2. All right, so that'll be 24.31 for our magnesium, there's only one of it, plus 35.45, that's our chlorines, times 2. So molar mass, (95.21) grams per mole. Okay, so now I have big M and I have N, and I'm looking for M, little m. So I have to manipulate my equation, multiply both sides by big M, and now I can solve for little m. So little m will be, okay, my 8 moles multiplied by my 95.21 grams per mole. It's 8, right? All right, so we're looking at 761.68. What are my units? Grams, right, so it's looking for mass. Okay, how important are units? Vary if you want the mark, yeah. Okay, if you don't want the mark, then they're not all that important, but I assume most of you want the mark, so don't forget your units on your answers. Okay, how many people have done number 3? All right, so on number 3, we are looking for now the number of molecules. Does this one involve the step with Avogadro's number? It does. So we're looking for the number of molecules. That's our question mark. Okay, we do know that the material is sodium sulfide. Okay, Na with S, sulfide's a -2, sodium's a +1, so we got Na2S. Okay, guys, another thing here for your unit exam, because I see this happen. People have a tendency to want to go fast, and they don't double check things on their periodic table. And then I get stuff like that. Instead of getting this, I get this. Like people don't, they just write down SO or something like that for sodium, right? They don't look up the formula. They just, yeah, just don't do silly things like that. I see that when people are rushing, okay, or they're a little bit anxious or stressed or whatever. Okay, make sure you double check. That's why we give you the periodic table, so you don't have to be anxious and stressed. You have all of that information there. All right, so we got 22.99 grams per mole times 2 for our sodiums plus our 32.07, right? Okay, for our sulfur. So 22.99 times 2 plus 32.07, and we're looking at 78.05 grams per mole. Okay, the other thing the question tells me is that there are 200 grams of sodium sulfide. Okay, what can I find with little m and big M? Right, I can find number of moles, right? I can find n. Okay, so n is going to be little m over big M, so that'll be 200 divided by 78.05. Okay, so we have 2.56 moles. Now obviously I want to keep all those decimals, I just don't want to write them all down because I'm lazy. Okay, 2.56 okay, moles. What can I do with that number and Avogadro's number to get my number of molecules? Okay, remembering that Avogadro's number is the number of molecules in 1 mole. I have 2.56 moles. What do I do with those two numbers? I multiply them, exactly. Okay, so I take my 2.56 and I'm going to multiply it by Avogadro's number. Okay, so taking that with all the decimals, multiplying by 6.02 and 23. Okay, so I'm going to have 1.54 times 10 to the 24 molecules. Questions on that one? All right. Finish up number 4 there. We'll go over that one in a few more minutes. If you're done those 4, then I want you to go back to those mole equation worksheets. Okay, and see if you can finish those up. Okay, so for number 4, right, we've got, we're looking for the mass, so we're looking for little m, and we're told the number of molecules. Okay, 1.2 times 10 to the 25, okay, and we're told that it is iron 2 nitrate. So that means the iron with the 2+ charge is with NO3, which has a -1 charge, which will require brackets and a 2 outside of the brackets. So that'll be 55.85 and plus 2 nitrogens plus 5 oxygens. And so 55.85 is our irons, plus 28.02 is our 2 nitrogens, plus our 5 oxygens. Okay, 163.87 grams per mole. Okay, so now we know the mole mass, right? We do. Yep, we absolutely do. Good eye. 6 oxygens, not 5. 179.87. Okay. All right, so now we got that. We're looking for the mass. We have the number of molecules. If we're going to get mass, we still need number of moles. We still need N, and we don't have it. So we're going to use our number of moles, our number of molecules. And what are we going to do with it? We're going to divide it by Avogadro's number. This is the number we have. Avogadro's number is the number in 1 mole. Okay, dividing those 2 will leave us with moles. So we have 1.2 times 10 to the 25 over 6.02 times 10 to the 23. So our number of moles. Oh, don't want that funny bracket. Okay, so we're looking at 19.9 moles. Okay, we'll keep all of our decimals, but I'm only going to write that many. Okay, now that I know the number of moles, now I can calculate mass. Mass will be number of moles times the molar mass, okay, because we just manipulate, right? Multiply both sides by big M. Okay, and so that will give us our 19.9 times our 179.87 with 6 oxygens, not 5. Okay, so we're looking at 3,585.45 grams. Everybody all right with that one? Okay. I'm really leaning toward one of each kind for 4 of them on your unit exam right now. Okay, the deciding factor is going to be how long it takes me to make the key. Okay. And that's not to save me time. It's actually to make sure the test is fair. Okay. Did I tell you guys this already? The formula for deciding whether a test is fair. Okay. So here's what I do. I make the test up. Then I make the key, and I time myself for how long it takes me to make the key. If I can divide the length of the class, 85 minutes, by 3, and still get a number that's bigger than what I got, the test is fair. If it's 4, then the test is easy or short. Okay? So generally, if it takes me around 20 minutes or so, okay, to write the key for the test, then the test is pretty fair. I figure it should take you between 3 and 4 times as long as me to write the test. Okay? So that's how I figured it out. So I'll either be keeping that 4th mole question or dropping that 4th mole question depending on how long it takes me to make the key. Okay. So. All right. Questions on any of the ones from yesterday that you worked on, Mr. Banner? Mr. Banner said you guys were really good yesterday. So.
Just something that I wanted to make sure with you on one of the questions on the worksheet. It asked for the amount of oxygen atoms.
Yes.
And I asked if I could use 16 for the molar mass instead of 32.
Yes, you can. And that will give you the number of atoms. That, or you use 32 and then just multiply that number by 2. Okay, so here's what David's talking about. Okay, you had a question that said how many oxygen atoms. Okay, so how many I don't remember what the mass was. We'll just say 100 grams for now. Okay, in 100 grams of O2. Okay, so when you do this mole calculation, okay, you go N equals little m over big M, and you go 100 grams divided by 32 grams per mole, because the molar mass of oxygen molecules is 32 grams per mole, because there's 2 oxygens in there, right? But when you do this calculation, okay, and you get the number of moles, so it comes up to 100 over 32, okay, you get 3.125. Okay, then I take that and I multiply it by Avogadro's number. But I have to remember that when I do that, I'm calculating the number of oxygen molecules, not the number of oxygen atoms, because I used the molar mass of oxygen molecules when I did this calculation, and that's the way most people would do it. Okay, and so they would go, all right, the number of molecules is that number times Avogadro's number, and so they just go times 6.0223, okay, and they get this number. All right, there's my number of oxygen molecules. But each one of those molecules has how many atoms in it? 2. So you got to multiply that number by 2. Okay, so it's fine to do it either way. You could have done this originally using 16, and you would have got twice as big a number to start with, and you wouldn't have had to multiply by 2 at the end. Okay, either way will work. Okay, all it's doing is checking your understanding of the difference between an oxygen atom and an oxygen molecule. That's all that question is doing, because I know you can do that mole calculation, no problem. Okay? It's checking your understanding of the difference between a molecule and a single atom. Okay? Had that question been about iron, it would have been way easier because we wouldn't have thought a thing about it, right? Iron always comes as a single and we would have just done it. Okay, other questions from the worksheet from the other day? Okay, so let's keep working on those. Remember, I did post the keys for that the other day. Okay, I will be doing your unit exam review tomorrow. Okay, so I will go over all the key points from this unit. I'll talk about how I like to ask questions about those topics. And then I'll tell you how many questions / marks and stuff are on your unit exam. Okay, now, here's the thing. Tomorrow's Friday, short day, so there's no help tomorrow. Tuesday's a PD day. You don't have school. I do. Sucks for me. Good for you. Okay? Wednesday's your test. So today is really your last day to get help unless you come with questions tomorrow. Okay, so my suggestion would be do some review tonight so that after I do the exam review, which will only take me 20 minutes, okay, of tomorrow's class, have the questions you want answered tomorrow and you can ask them in class, and that's kind of the idea. If people don't have a lot of questions, I kind of scramble to cover a few things here or there and then give you review time to go over the review package. Okay, so your best use of time tomorrow is to keep me busy by having lots of questions to ask, okay, and things to go over. Like, Mr. Coderre, can you go over a tricky balancing question? Or Mr. Coderre, can you do another mole equation question? Well, we calculate the number of molecules or whatever. Have questions for tomorrow. Mr. Coderre, can you review the naming rules for polyatomic ions and multivalent metals? Whatever. I'm here to answer your questions tomorrow. So the more of them you have, the better that is for you. Okay? So keep that in mind for tomorrow. All right, if more questions come up on those worksheets, okay, then I am happy to answer them. Okay, but let's just kind of keep going on those. You could also be working on, if you wanted, your review sheet, okay, if you're feeling good about the mole equation. Okay, I'll leave that up to you.